Hey everyone, Morgan here. So we're going to be talking about something called combustion problems today. And this is a very old school approach to determining empirical formulas. And this technique has been replaced by modern technology, but it is still something that's very popular in question writing with the AP exam and with the chemistry Olympiad. So when you burn something, you form oxides. And typically when we take something that is organic, say CXHY, and you burn it in O2, you're going to get CO2 and you're going to get H2O. And those are going to come off as gases. So if you were to actually burn something that is organic completely, which means not just throw it into a fire, but to pump in some extra oxygen and use a catalyst to really convert it entirely to CO2 and H2O and no other byproducts, you could collect these gases. Okay? Now, how are we going to do that? It is actually a little bit tricky. Okay? You're going to need to use what is called a U-tube. Now, it is literally glass that's in the shape of a U. And it has a little side arm that comes off. And what we can do is we can hook plastic tubing onto it. And so we can send a gas through there. Now, for our first gas, or for the first U-tube, what we're going to do is we're going to put a liquid in here. Okay? And that liquid that's going to fill this up is going to be P2O5. So when the water that's in there hits the P2O5, it's going to form H3PO4. Okay? And the mass of this tube is going to increase. Now, typically you have some rubber stoppers in here to prevent gases from coming out. And then on this side, another piece of rubber tubing that takes it to a second U-tube. And this second U-tube, terrible artwork for which I apologize. You can look this up online. Now, the second one is going to contain sodium hydroxide, NaOH. So the NaOH will react with CO2 and form NaHCO3. Now, the P2O5 and the CO2 are not going to react with each other because they're both non-metal oxides. Okay? So the P2O5 only reacts with H2O. And the amount of mass increase that you get on that tube will solely be from the added water, and the mass increase on this tube will solely be from the added NaOH. Okay? Now, typical problems involved here. Naphthalene, you've got a molar mass of 128.18. Okay? Combustion of a 3.000 gram sample of it produces 10.30 grams of CO2 and 1.686 grams of H2O. What's the molecular formula? So let's go with an approach that we all understand, the classic roadmap, 10.30 grams CO2. Now we're going to use this just to turn this into grams of carbon. We can say 1 mole of carbon, 1 mole carbon dioxide. 1 mole carbon dioxide is 44.01 grams of CO2. Then 1 mole of carbon dioxide gives us 1 mole of carbon. 1 mole of carbon is 12.01 grams of carbon. Now, You've seen this before. You know how to do this. There are other ways to do this, of course, but I don't want to bother introducing you to a dozen different methods if you already know how to do this method. 2.811 grams carbon. Okay? Now, our next number is 1.686 grams of water. Times 1 mole of water is 18.02 grams of water. 1 mole of water has 2 moles of hydrogen, and 1 mole of hydrogen is 1.01 grams of hydrogen, and this equals 0.189 grams hydrogen. Now, it's time to actually start thinking on higher levels. I didn't have to do both those calculations, because if you'll notice, those two numbers add up to be 3.000 grams. So if I know the grams of carbon, I automatically know the grams of hydrogen. Okay? Because they both have to total 3 grams in this case, because there's only carbon and hydrogen present. Now let's go for an empirical formula. 2.811 grams carbon and 0.189 grams hydrogen. 1 mole carbon, 12.01 grams hydrogen. And that equals 0.2341 moles carbon. 1 mole hydrogen is 1.01 grams hydrogen. That's 0.1871 moles hydrogen. I'm going to divide by the smaller number, which is the 0.1871. That equals 1, but this equals about 1.25. So to get these to whole numbers, I'm going to multiply both by 4, because 1.25 is a fourth, and that equals 5, and this equals 4, so it's C5H4 is my empirical formula. Okay? Now, if the molar mass is 128, does this molar mass equal 128? 5 times 12 is about 60, plus 4, that's about 64. So 128 over 64 equals 2. So I multiply this by 2, and I get C10H8 as my formula for naphthalene. Okay? All right. Now, we're going to go to 3 elements this time. Carbon, hydrogen, and oxygen. Carbon, hydrogen, oxygen. It's acetic acid. We already know what the formula is. We have 1.000 grams. Now this time we get 1.465 grams carbon times 1 mole carbon, 12.01 grams carbon. I'm sorry, it's 1 mole carbon dioxide, and that is 44.01 grams carbon dioxide. This is CO2. My bad. Apologize for that. 1 mole CO2 as 1 mole carbon. 1 mole carbon is 12.01 grams carbon. All right. 0.3998. grams carbon. Now for the hydrogen, it's 0.6000 grams of water times 1 mole of water is 18.02 grams of water. 1 mole of water is 2 moles of hydrogen. Okay, and 1 mole of hydrogen is 1.01 grams of hydrogen, and this time I got 0.0673 grams of hydrogen. Now, these do not add up to be 1 gram. That's because I've also got the oxygen to contend with. So what I can do is just say 1.000 minus these numbers, and that gives me 0.5329 grams of oxygen. So an empirical formula, 0.3998 grams carbon, 0.0673 grams hydrogen, and 0.5329 grams oxygen times 1 mole carbon, 12.01 grams carbon, 1 mole hydrogen, 1.01 grams hydrogen, 1 mole oxygen is 16.00 grams oxygen equals, okay, 0.0333 moles, 0.0666 moles, and 0.0333 moles. Well, I'm recognizing that ratio. Divide by the smallest. Equals 1, equals 2, equals 1. CH2O. The molar mass of CH2O is about 30 grams per mole. I'm told the molar mass of about 60 over 30 equals 2, so that's C2H4O2. Or, more precisely, the way we might write it would be H C2H3O2. Okay. So, now I'd like you actually to proceed to the next page, to page 10, and try those 2 problems on your own. But I am going to warn you, they are more challenging, okay? And one of them has a pretty good trick in it. All right, this is Morgan signing off.